Okay, so I'm clearly not an early researcher, an early career researcher or a mid-career researcher. I'm what Tracy kindly called a established researcher. I may be, so I think it's more late career, almost end of use-by date researcher. Anyway, what I'm here to talk about and perhaps stimulate you and perhaps even pique your interest, either in yourselves or potentially relatives or friends, is a trial that we're going to be undertaking very soon, which is going to take about 4 years to complete, in the effort to try and prevent Alzheimer's dementia as part of an international trial. And the name of the drug is that, almost unpronounceable, but the trial is called Skyline, and it's funded by Roche actually. Just to set the scene, and we've already heard a bit about dementia and young onset dementia, but the prevalence, in other words, how many people at any one time have dementia, Alzheimer's dementia especially, which is the most common dementia, it varies or depends very much upon our age, and you can see there that it increases quite dramatically as we get older. And you know, by the time we are 85, a third of us will perhaps live with dementia. So it's very much an age-related disorder, and if you look at that figure there, people have calculated that if you're 65, which is I'm just beyond now, my risk of being diagnosed with Alzheimer's disease increases by about 2% per year, and it increases a little bit to 2.5% per year if I've got a family history, in other words, a first-degree relative, either a parent or a sibling. Now, the thing about Alzheimer's dementia, as many of these other neurodegenerative disorders we've heard about, is that it doesn't happen just like that. It gradually progresses over time in a very subliminal way that we're not aware of in our brains. And so, for example, if you look at that graph, there's what's regarded as the preclinical phase of Alzheimer's disease, which actually goes on for about 15 to 20 years before we actually develop some cognitive impairment. Now, as we age, we also develop a little bit of cognitive impairment as a normal phenomenon of aging. And so it's normal to get a bit of memory loss, to wonder where you left your keys, where the car is in the supermarket car park, those sorts of things. But there's a bit beyond that, which we call mild cognitive impairment, and that's a preamble to dementia. This thing takes time. And so clearly, if we can intervene at an early stage, that might be the answer to try and prevent this disorder. Now, you heard about the amyloid protein that Campbell mentioned, and we know from previous studies that during that preclinical phase of 15 to 20 years before we actually get trouble with our memory and thinking, there are changes going on in the brain with these abnormal proteins that Campbell mentioned. And what happens first is the amyloid in the brain. We all need amyloid, normal amyloid, but the amyloid goes a bit wrong, and it gradually increases over time, over those 15 to 20 years, before it then starts to be equated with having trouble with your memory and thinking. After the amyloid, as amyloid plaques, sometime later, there's another protein called tau which also accumulates. And so it's these two proteins that together cause Alzheimer's disease, or associated with Alzheimer's disease. Whether it causes Alzheimer's disease is a matter of debate, but it certainly is associated. Now, the amyloid, which seems to be the main player here, we already know that if you produce antibodies and inject them into people who have amyloid, we can clear that amyloid from the brain quite successfully. And there's been quite a large number of trials over the last decade or so that you will have heard about, and if you look at those pictures, along the top are 4 people, each with having abnormal amyloid in the brain. They've been treated with one of these antibodies against the amyloid, and down the bottom of these 4 people is what has been cleared from the brain, apart from the one on the left which had the placebo, the dummy drug, and so no amyloid was cleared. So we know we can successfully clear the amyloid out of the brain in people who already have either early dementia or established dementia. But it hasn't equated to any benefit in those people, despite the clearance of the amyloid, which is a hugely disappointing, and a huge amount of money has been poured into this. So the message probably, or what we believe, is that clearly we've started the treatment too late, and we need to start sometime before any cognitive impairment starts. And that's the idea behind the trial I'm just about to mention. Before I do, there is one current trial being undertaken and not the one that we're about to do, but a current trial that has really not been published. All we know is about the baseline characteristics of the people who have volunteered for that particular trial, mainly in the States. And they were between the ages of 65 and 85. A lot of people expressed interest, 15,000. That led eventually to 4,500 about people having amyloid PET scans, and they're about $2,000 to $3,000 each, so there's about $8 million spent on those scans. 30% of those people who volunteered for that study had a positive scan, in other words, had abnormal amyloid in their brains in that age group, so quite a high percentage of those people. Now, if you have amyloid in your brain, it doesn't mean to say you're going to get dementia. If you get Alzheimer's dementia, you have to have amyloid in the brain, but having amyloid in the brain doesn't mean you get dementia, because there are many protective factors that prevent people who have got abnormal amyloid in the brain from getting dementia. They may have genes that help protect them. They may have a lifestyle factor that helps protect them. They may have start off with a very high cognitive ability, which then means they've got further to drop before they get dementia. So a lot of reasons, and we know that quite a number of people who have amyloid in the brains never get dementia. We know that because they get run over by a bus and there's a post-mortem and you can find amyloid and they've been perfectly fine in life. So I don't want you to think that if you've got amyloid in the brain, you're going to get dementia, but you're at risk of getting dementia. And that risk is increased in people who've got a certain genotype called ApoE4, which we can measure in the blood. And if you have a family history, as I've mentioned, but the family history is not a huge component, it just adds a bit. Which now I turn to the actual study that we're going to be part of a large international study sponsored by Roche, using one of these antibodies which mops up amyloid in the brain. And it's designed for people who have normal cognition, right, who haven't developed any significant memory or thinking problems. You and I here. And so that's who it's designed for, in the effort to try and prevent the dementia occurring in people who are at risk. And so the people at risk are going to be the people who have amyloid. So we have to establish the people who have amyloid from the people who don't. And so the people who are going to be enrolled in the study, or who might be interested in the study, are between the ages of 60 and 80. So these are the populations, as you saw before, that are sort of at risk of getting dementia imminently. But you have to have normal cognition, and we measure that. And the folks who come into the study, who volunteer, have to have generally good health. So we don't want to have people who we can upset the apple cart for. Then we have to show that those people, those volunteers, have got abnormal amyloid in their brains. And we expect about 1 in 6, based on the figures that we know of people out there in the community who have amyloid and don't know it. About 1 in 6 of the volunteers we expect will have abnormal amyloid. So there's a sort of a staged process as to people volunteer, we see them, check their memory and thinking, check their general health, then we do some screening tests to see if they may have amyloid. And so at each stage, the people will sort of drop out, if you like, because they don't qualify. That's good news or bad news, depending on what you think. And then we end up with people who have only got amyloids in their brain, abnormal amyloid, and they are the people who are able to go on and have the treatment. And the treatment, so there'll be 600, this is internationally, 600 people on the dummy drug and 600 people on the real stuff. So if people go into the study, you don't know, and I wouldn't know, what you're getting. You have to do this to know that the stuff really works. And so you could go into the study and get treated, and it's a 4-year study. It's a long haul for people, so you've got to be a bit sort of robust and committed to go into the study. There'll be regular clinic visits and so forth, but 600 people internationally, half getting the real stuff, half getting the dummy. Of course, no treatment known to man is free of side effects. Paracetamol, you name a drug, someone will have side effects. And this is no exception to this type of treatment. So the most common side effects we may expect from other studies that have been done with a similar antibody are headaches, but not necessarily severe and easily treated. Injection site problems. This is subcutaneous injections under the skin, like a diabetic does. And you can get injection site irritation and so forth, but they're usually easily managed. The main potential side effect, which is specific to this type of medication, is called ARIA, which is basically a specific response in the brain to this type of antibody treatment. And it's related to sort of leaky blood vessels and so forth that this initiation of treatment induces. But in this particular study, because we're going to bringing in the medication rather slowly, we are hoping to reduce the incidence of that. But this is, some people can get little brain hemorrhages, tiny little bit well, it's not really hemorrhage, it's really leakage of blood into the brain, or more commonly the brain surface. And some people get a bit of temporary swelling in the brain, a little bit of water on the brain, if you like, which can cause headaches. But they tend to go away with treatment, as you can see in the bottom panel there. That's before, during, and then after the first treatment. So I don't want to scare people off, but you've got to be aware that any trial of a new medication can have potential side effects. It depends on your ApoE status. This is the gene test that will be part of the study. It's a two-edged sword, the ApoE status. There's an ApoE, a type of gene called ApoE4, type 4, and if you have that, then you are more at risk of getting Alzheimer's disease per se. But on the other hand, if you have that, then you've got more to gain by having this treatment potentially. But we will be checking people's ApoE status and letting people know once we have it. So this is really my penultimate slide, just to really just reiterate the process of this particular, I think it's an exciting study, and this one and the one I just mentioned before, the one that's already running, these two studies, international studies, are really going to be the answers to whether this type of treatment is going to be useful for preventing Alzheimer's or not. If it fails, if the two trials fail, that'll be the end of the amyloid story, and we'll have to look at other things, maybe looking at tau protein, the other protein, or maybe looking at completely other things. But it's going to be definitive. So the process, you won't be able to read that from the back of the room, but essentially, I'm just reiterating, it's what I've said before. We'll be advertising in the local newspapers very soon, and with some adverts sitting out the back there if you're interested in taking one, which has our contact phone number and email, and I'll mention that in a second again. Then there'll be a phone interview with the people who have expressed interest, just to let them know more about the study and to see if they may be interested, and also to see if people might be eligible. There'll be no point you having lots and lots of investigations if you're not at all eligible because maybe you've got terrible heart disease or something like that. Then there's going to be, this is another interesting facet, there's going to be a blood test. For people, you don't have to have this, but the blood test is it's a new thing that has only just come into the literature now, where you may have, and you may have heard it in the newspapers, where you can have a blood test that may give you some indication, or not you, because we don't know, we will never hear what the result of that blood test is, neither will you exactly, but it'll give an indication potentially of the likelihood that you may have amyloid in your brain or not. It's not a precise test, but it gives a rough indication, a reasonably good indication. And that will be a pre-screening test, so that if you look like you don't qualify because looks like you don't have amyloid in your brain from the blood test, it saves you going through the next step of the process, which is very involved. It involves blood tests and scans and so forth. Then if you pass that particular step, you then go into the what's called the big screening part of the trial, where we look at, we clinically examine you, we do a whole lot of blood tests checking that you're healthy. We do scans, MRI scans, you've seen examples of that, and that amyloid PET scan. So some of those people who get into this stage will not have amyloid in the brain. And so those people will not qualify to have the treatment, because obviously no point giving the treatment for something that isn't there. So folks who don't have amyloid in the brain, they can say, well, that's good, I don't seem to have a risk for Alzheimer's, but that means you don't get into the trial, obviously. And then the people that do, they have the opportunity of then going into the study. And then they're committed. Well, you can pull out any time you like, but if you want to be in it, then it's a 4-year trial of subcutaneous injections under the skin that's either administered by the clinic staff or a nurse that comes out to the home, or you can do it yourself, or you have your partner doing it. And that's every 1 to 2 weeks. Your option of do it once or once every week or once every 2 weeks for 4 years. Because you've got to give it a decent time to know whether it's going to work or not. So it's a big commitment, but I don't want to put people off because but you need to know what you're getting into, right? And then that will be the end of the study, but it's going to be 2024 or much later than that actually, 2028 before the trial will be finished. So that's really it, and this is an advert that will be in the papers in the near future, and there's some sitting out there in Kyla, and one or two of other researchers are there if you want to grab it. You don't have to commit yourself, you just grab the advert and take it home. It's got the contact numbers, which we monitor every day, and then people who express interest, we will ring you or ring the people who express interest and check that, and just go through a list of things that you want to know about and check that you might be eligible potentially. And so you're welcome to grab those. So, we're hoping this is going to be effective. If it is, it's going to be a major revolution in preventing Alzheimer's, an expensive prevention thing in the end. But we're looking forward to doing the study and seeing where we get to. So look, thanks very much for your attention. You've heard some wonderful talks by our younger researchers. They continually amaze me at their enthusiasm, how bright they are, the tremendous work they've done. So I'm always amazed by our young researchers. So look, thanks very much for coming tonight.